Welcome back to the next part of every single way to solve for x part 1. So we left off at number 3, the absolute values. We're now at number 4, solve each inequality and graph its solution. So we're going to deal with less thans and greater thans like that. Okay, I don't see any absolute values, just regular parentheses. So I'm just going to regularly do my thing and distribute on both sides. On both of these terms inside the parentheses. Negative 8 times negative 1 is positive 8. Negative 8 times 4 is negative 32n. Greater than or equal to negative 216. Okay, take that 8 out, subtract 8 on both sides because it's positive. Woo. Okay, negative 32n is greater than or equal to negative 224. If you want to check your work, you always can. Negative 224. Okay, and then we are going to divide both sides by negative 32. So when we divide both sides by negative 32, it will be a 7, but there's a reason why I'm not putting this part over here just yet. Whenever you divide by a negative, okay, divide or multiply by a negative, you need to switch the inequality. So instead of a greater than or less than, instead of a greater than or equal to, it's going to be a less than or equal to, and then that's going to be your solution. So n is less than or equal to 7. Let's go ahead and graph it on the number line. Because there's an equal to sign, it's going to be a closed dot. Okay, so closed dot. Otherwise, if you don't see an equal sign, it is going to be open. So let's close it on the 7. And then we want numbers that are less than 7. So the numbers that are less than 7 are 6, 5, 4, 3, 2, 1, etc. You guys can graph it like this. Since I'm doing black, it's going to be hard to go black on black ink. So you guys can graph it like this, and that should suffice, like that. Okay, or you can graph it on the actual number line. It's totally fine. So you need both of the solutions for number 4 just like this. Okay, so that's number 4. Let's move on to number 5 and 6. And I think from there I'm just going to stop the video. This time around, we have an absolute value for number 5 and 6, and let's do that one by one. Let's get rid of the negative 9 first. I'm just going to add 9 on both sides. Okay, and then I will put the rest of the calculations underneath. Absolute value of 4n minus 9 is greater than 41. Okay, I'm going to write a small rule somewhere over here. If you have absolute value of x is greater than a, so it's a little bit different. If there was an equal sign, you would do it like this, okay? So if there's an equal sign, you're going to split it up into 2. If you have a greater than sign, you are also going to split it up into 2 parts. So it's very similar to the equal sign. You're going to have x is greater than a, or x is less than negative a. Super similar to as if there was an equal sign over here. So let's follow that rule. You can only do it when you have the absolute value already isolated on one of the sides, which is what had happened here in number 5. So let's go ahead and apply that rule right now. 4n minus 9 is greater than 41. Then your next one is going to be 4n minus 9. So notice that the left sides are not changing, but this part changes now. Less than negative 41. Okay. So now you got 2 separate equations, 2 separate inequalities that you're going to solve for, and let's just solve them. Add 9 on both sides, add 9 on both sides. Okay. So 4n is greater than 50. And then we're going to divide both sides by 4. N is greater than 50 over 4. 12.5. You know, 12.5 is okay. Or you can transfer that back into a fraction, 25 over 2. So either one is going to be fine. 25 over 2, they're the same representation. But the 12.5 is just a little bit easier to graph. Okay, 4n is less than negative 41 plus 9 is negative 32. Okay, we're going to divide both sides by 4. And this one should be a whole number. N is less than negative 8. Okay, so we're going to graph these two right now. And I think maybe I'll just use a different color for this one. So we're going to graph two different ones. N is greater than 12.5. So on the 12.5, which is, I guess, somewhere over here, I guess, yeah. It's going to be an open dot because we don't have an equal to sign over here. So it's going to be an open dot, and things that are greater than 12.5, which is 13, 14, 15, 16, 100. And then we're going to draw that arrow over here. And then with that, we also need to add n is less than negative 8. So on the negative 8, we're going to open dot again because there's no equal sign. And we want things that are less than that, which is negative 10, negative 12. And then we're going to put that over there. Okay, so those are your solutions, the graph, your inequalities and the graph for that, for number 5. Okay, now let's do number 6. And then I think after number 6, I'll stop the video. We'll move on to the next video. Okay, number 6 is this. Negative 4 times absolute value of x plus 4 is greater than or equal to negative 20. So I do want to remind you guys that don't distribute over here. You would just want to undo what's outside of the absolute value. I want to remind you guys that this is negative 4 times. So to undo that, we're going to divide both sides by negative 4. Okay, absolute value of x plus 4. And then negative 20 divided by negative 4 is 5. Remember our rules from last time. So when you divide by negative, what happens to your inequality? So remember, we got to flip that. So we're going to flip that into a less than or equal to sign. Okay, we have a rule for absolute value greater. There's another rule for absolute value less than. So I'm going to write it over here. If absolute value of x is less than a, you are going to change it up like this. Then it's going to be negative a less than x less than a. Okay. All right, so let's follow through with that. So what we're going to do is we're just going to transform it over here. So let's take that a value, which is 5. We're going to make it negative. Less than or equal to x plus 4, because there's a less than, and then another less than or equal to, and then that 5. Okay, so just making sure that that structure works out. Okay, now to solve for x, you're going to subtract 4, not just only on the left, not just only in the middle, but all sides. Okay. All right, so when it comes down to it, this is going to be negative 9 is less than or equal to x, less than or equal to 1. Okay, so when we do the shading portion for number 6, it's going to be a little bit different. Okay, and here's how. We're going to start at the negative 9, which is over here, and it's going to be a closed dot. And then the 1 over here, and it's going to be a closed dot. But you see the x is in between the negative 9 and positive 1. So we're not going to shade outwards when we do the less thans. We're going to shade inwards like this, because we want the x values to be inclusive inside the negative 9 and 1. So all the solutions, so whenever you're doing inequalities, all these numbers work for this particular equation. So that's what's happening with number 6. And then as opposed to number 5, what we're showing you guys is that all of these numbers outside of 12.5 and outside of negative 8, those work if you plug them back inside the regular inequality. Okay. All right, so please note the differences whenever you're in this middle step over here. If you have absolute value greater than a, you're going to split it up into 2. If you have absolute value less than a, you're going to make it into one long equation. When you have the absolute value greater, your solutions are usually split. You got to go to the left and right shade. And then when you have the absolute value less, you are going to shade it inwards like this. And then just to give a small reminder, well, what about the equals? Well, for the equals, that was at number 3. When you have equals, you're going to split it up as positive and negative, and then you're just going to have like pretty much like 2 dots. There's no shading. It's either x equals 6 or x equals negative 14 over 3, like 2 dots on the number line, and then that is it. Okay, I'll see you guys on the next video.